Hello developers, welcome to my video series on Microsoft Flight Simulator add-on workflow. Today we are going to learn about Virtual Cockpit, basically the panels. The files that are associated with the panels in your aircraft are the instruments and gauges. The panel folder is right next to the model folder. It will contain a panel config file and possibly a panel XML file. If you are familiar with FSX, the panel folder used to contain the 2D panel XML files, sometimes inside cab files. And there were also .gau files, gauge files, which are really DLLs or dynamic libraries written in C++. The sim no longer allows these types of DLLs. They are replaced with WASM modules, WebAssembly modules. Technically, they're still DLLs, but they're more restricted. WASM modules are compiled C++ files also, and they run as native code. The 2D XML files are now 3D gauges, but the XML is in the model folder rather than in a panel folder. And the instruments are coded in XML in the model definition file now. So what's left now are the panel files, and the panel config file has a list of instruments that use textures as a means to be displayed. The instruments are usually grouped as a glass cockpit type instrument. Ones that are numbers and letters and graphics that display on a screen. The 2D instruments are gone and now they are replaced by 3D instruments. The typical six-pack of instruments with needles and markings are all now 3D or three-dimensional. You have to model the needles as 3D objects and they get animated. So they would rotate around a center point like you see on a normal type of gauge. The other panel file, the panel XML file, is also part of the glass cockpit. The panel XML file contains the aircraft-specific information that the gauge displays, like the maximum airspeed points, the points on the airspeed markings that are white, green, yellow, red. Similarly, the volts on the voltmeter, where it's green, where it's yellow, where it's red, etc. The glass cockpit gauge is displayed with WASM modules or JavaScript, CSS, HTML files. This is a completely new way for gauges to be made and displayed. We'll go on to more detail on how these are made in a later episode, but right now we just need to know that there are different ways to do the gauges now. If you have FSX aircraft, you can make your gauges compatible with Microsoft Flight Simulator by using what's called the Nano VG API. That replaces the GDI plus C++ libraries. And there is a sample aircraft that will show you this. Read the SDK documentation on WebAssembly in the Programming API section. When you start looking around the sim and see that the default aircraft, you'll be able to understand what's happening when you peek at the files. Let's look at a typical panel config file from the gauge aircraft. Open the Sim Objects folder, you know where it is. Go to the panel folder and look what we have here. So we've gone to our gauge aircraft panel and we have a panel config and a sample WASM module.wasm. But we do not have, in this particular case, a panel XML file. Let's open the panel config file in Notepad. And there it is. So in the panel config, you have a section designated vCockpit 01 in square brackets. So up here, the next lines describe how the gauge is to appear in the sim. You have things like size in millimeters with key value pairs, Size in millimeters 1024 by 768. The pixel size 1024 768. The texture that the gauge is going to appear on, and in this particular case it's $screen_1. You can even have a background color. In this case it's 00255 or blue. And then the last item, which is relatively new, is the HTML gauge 00 key with a value of WASM/WASM instrument HTML $WASM module equals WASM module dot WASM ampersand WASM gauge equals compass, and then again a bunch of numbers at the end. We'll explain these in a later episode. And you can see that there is a vCockpit 2 and a vCockpit 3, and we can kind of guess what instruments they are also. So in this particular case, the gauge aircraft has 3 instruments. Let's build the gauge aircraft, and you should know how to do this. Open the project file, the gauge aircraft folder, select the project, open the inspector tab, and build. Then when the build is done, we'll select the gauge aircraft at the world map, and then we'll go fly it. And when we fly it, we'll be starting here on the runway, and you'll notice that we have the gauge aircraft, but this time we have an interior. We have an interior with 3 gauges. And this aircraft is more complicated than the simple aircraft. We have those 3 gauges now, and you can see that they're basically the glass cockpit type configuration where we have a screen and we have a gauge on one screen, the compass, we have the pitch on another screen, and I guess this is the demo. Just the ability to make all sorts of graphics on a screen. And they should work. Let's see if we can get the compass to indicate something. And you see that the compass moves. So the WASM file is just a compiled C++ file, so we can't really open that up in Notepad. Well, it's just like an exe file or a DLL file. It's all compiled code. But what we can do is we can go up to the sources and code section, and here we have the C++ files, and let's have a look at what we have there. So we have an attitude indicator and the compass, and we have the demo. Let's open up the attitude indicator in Notepad, and we see that it's C++ code. I don't know if you can make any heads or tails out of this, but basically a small amount of code to allow you to create a gauge. The SDK docs have an entire section on the programming API, so there's a lot of information there, and you can see code examples and so forth. Not only can you use C++, but you can also use C# if you'd rather use that, but most programmers use C++. I've opened up Visual Studio, and I've opened up the C++ project for the sample WASM module, and you'll see again that I have the 3 different CPP files for the 3 different versions of the gauge there. So what's happening inside the panel config here is it's pulling the information from the WASM module, so the sample WASM module.wasm file, and then it's pulling a specific gauge, the compass, attitude, and demo gauge out, which relates to our compass, attitude, and demo gauge information here. That's brilliant. So you just need to make one program file and you can have as many gauges as you like inside. If we look at all the CPP files, we can probably figure out what's going on there. There are some includes of information, structures on how things are to be saved, so callback files, panel services, and I guess a bunch of calculation code that it requires. A bit too complicated at this point, but we'll get to that later. There are also other instruments that can be made from JavaScript code. In fact, I don't see any regular sample aircraft with JavaScript, so we'll have to dig into the other sample, the DA62. So if we open up the DA62 panel config, we have the typical vCockpit section, but this time our HTML gauge 00 has a nav system down to a WTG 1000 underscore MFD.html. HTML files are supported by JavaScript JS files to make them work. And these are basically text files like those .cpp files, but with JavaScript code rather than C++ code. They're deep in the Microsoft official folder, so let's use the File Explorer and see if we can find that file. So it's deep in the official folder. See if we can find it using file folder. There we are. If we open that in Notepad, we have an HTML file that, well, it's kind of difficult to explain if you don't know HTML. But just understand that these div sections or tags with IDs have certain functions. We can kind of understand that a G1000 has a number of keys that you press along the bottom. So the key information is in the HTML. Then we have a bunch of JavaScript files that we need to use. So it's a very complicated system. So we have a number of JavaScript files or JS files that are used. The one here, Microsoft, or just the MFD, which is the multifunction display. Let's see if we can get to the location. And we have the JS file associated with this HTML. And let's open up it in Notepad. And here we have a number of classes in Notepad++. If I use the Alt key and press the number 2, I can sometimes collapse or down to a certain level. So I've collapsed all of the class files here just to make it a little easier to go through because it's a very, very big file. If we go down to the bottom, it's 29,000 lines long. So JavaScript, 29,000 line file just to get the multifunction display to work. Other parts of the panel config can have what's called V-painting section. We can use this to basically provide a dynamic registration for your aircraft. You can type in the registration number in your options and that'll appear on your actual aircraft. So if you have a favorite aircraft with a certain registration, you can actually put that registration on aircraft that have this type of configuration inside the panel config file. The DA62 has a panel XML file. We can open that up in Notepad and we can have a look at what it looks like. An XML file is basically a file with XML tags. I can use the Alt routine again, Alt 2 this time to set things at a level 2. If we expand an instrument section, we get the AS100 PFD, the synthetic vision is true, electric, and we have the word and then we have SimVar, and we have a circuit on 29. So a little bit of XML programming here. So there's a little bit of logic now that we can add to any XML file. We have instruments, we have logic, so probably naming for what's the PFD's name. It's called AS1000 PFD. What's the MFD name? AS1000 MFD. The panel XML, like I said, was a way for you to provide aircraft-specific information. So we have some enunciations for the left auxiliary pump on, again with an and a SimVar and an equals. So a little more programming here, a lot of enunciations. We have voice alerts, similar type things, state machine, state, value, transition, greater than or equal to, etc. So there's a lot of ways that you can program your gauges here. And then we have what we saw before, EIS. We have an engine display information, which actually has some actual gauges. So this gauge is a double vertical gauge. It's the load gauge on the pistons. So basically the aircraft engine information. Well, there you have it, a very simple look at the panel config and panel XML files for SimObjects. In our next episode, we'll look at the sound folder. And before going on to the next video, review any other sample aircraft, see if you can build them in the sim. The SDK samples also has a sound aircraft, so build that if you like. Try to understand all the files and folders that we've been looking at. And each sample shows a specific feature, but it still uses the gauge aircraft at its core. So good luck and see you next time.